Hi guys. So today we are going to look at our test review. So the first couple questions on there are those trig values that we have seen over and over and over again. So I'm not going to review how to fill out the unit circle. If you need more practice on that, you can check the quiz review video or the video that we did that went over the unit circle the first day. What I really want to focus on here is how to use it. All right, so sine is the y coordinate on the unit circle. So 3 pi over 2 is down here. The coordinates at that point would be 0, -1. So the y coordinate is -1. Cosine of 7 pi over 4, that's the x coordinate. So the x coordinate for pi over 4 is going to be the same as the other pi over 4s. In this quadrant, the x coordinate is positive. So the x coordinate is √2 over 2. Tangent is y divided by x. So I'm going to go to 2 pi over 3. It's going to be the same as the pi over 3s, except the x is negative. So -1/2 √3 over 2. So we're going to do y divided by x. So we're going to flip and multiply, which gives me √3. So, and it should be a -√3 because it's a negative divided by positive. All right, cosecant, we're going to flip y because it's the reciprocal of sine. So pi over 6 is going to have the same y coordinate as pi over 6, except it's negative because of where it's located. So -1/2, if we flip it, is -2. Secant, that's going to be the reciprocal of cosine. So we flip the x. Pi over 6, the x coordinate is √3 over 2. Now when I flip this, I need to get the square root out of the bottom, so I'll multiply the top and bottom by the square root of 3. And then the last one, cotangent. Cotangent is x divided by y, the reciprocal of tangent. So 5 pi over 4, that's going to be both a negative x and a negative y in that quadrant. So if I do x divided by y, well, that's just the same thing. And if you divide something by itself, it's 1. And a negative divided by a negative is 1. So those are your trig values. All right, so then again, we're going to look at those parent functions. I told you guys again, we need to focus less on the names and more on some of the characteristics of them. But just a refresher, cotangent, cosine, this one, it's an asymptote at 0. Now, normally, again, zeros turn into asymptotes. And since sine goes through 0, 0, then this one is going to be cosecant. Then we have secant, tangent, and sine. All right, so the characteristics, these are a little bit harder. The period of sine and cosine is 2 pi. But the period of tangent and cotangent is 1 pi. The period of cosecant and secant is also 2 pi. They are all 2 pi except for tangent and cotangent. All right, the zeros for sine. So again, if we're not sure about this, we can think about what the graph looks like. So sine has a period of 2 pi. Okay, if we divide that by 4, we'd have marks every pi over 2. And it looks like this. So the first 0 is at 0, and then they occur every pi n, because the distance between each one is pi. The other way you can think about it is just think about the unit circle values. Think about when sine has a y coordinate of 0. Well, over here it has a y coordinate of 0, and over here it has a y coordinate of 0. And if you keep going around that circle, you're going to keep getting those y values of 0. So it occurs every time you go past pi. All right, cotangent, again, you can think about the graph or you can think about the values. But cotangent has an asymptote at 0. Okay, cotangent has an asymptote at 0. So it doesn't start at 0. It starts at pi over 2 because that's what the graph looks like. So the first one's at pi over 2, and then again, we're adding pi n each time to get to each next one. It's not at 0 because, again, there's an asymptote because cotangent is undefined. If you're not sure, again, you can either think about the graph or think about your trig values. Okay, here's 0 on the unit circle. Cotangent is x divided by y. Well, 1 divided by 0 is undefined. So at 0, it doesn't have a 0. It's not equal to 0. But over here at pi over 2, 0 divided by 1 is 0. So pi over 2 is a 0. It gives you 0 as an answer when you actually find it. All right, the asymptotes for secant. Again, that's saying when is secant undefined. That's the same thing as the zeros for cosine, because asymptotes and zeros are flips of each other. So again, if you think about that cosine graph, it starts at the top, so the first 0 is at pi over 2. And again, that spacing is every pi n. And then the last one, the asymptotes for cotangent. So we just looked at that a second ago. The first one is at 0, and again, they occur every pi n. So you're probably noticing at least one thing that's similar. Okay, they're all adding pi n each time. So really, you just got to find where that first one or one of those values is to figure out which of these it's going to be. All right, finding the features of these equations, we've done this a lot now. All right, so amplitude is a number out in front, so that's 1. Phase shift is what you add or subtract to the x. In this case, we're not adding anything, so the phase shift is 0. The period is 2 pi divided by b, so that's 2 pi divided by pi over 2. So that's 2 pi times 2 over pi, which is 4. The vertical shift is what you add or subtract at the end, -5. All right, next one, amplitude's 1/2. Phase shift is pi. Period is 2 pi divided by 1 over 5. So times 5 over 1, which is 10 pi. Vertical shift is 0. There was nothing added or subtracted to the end. And then the last one, in order to find the phase shift, remember we need to rewrite that. So I'm going to do 2 and then x minus 3 pi. So my amplitude is 6. My phase shift is 3 pi because I rewrote it. The period is 2 pi divided by 2, which is pi. And the vertical shift is 0. There's nothing added to the end. All right, going backwards. So sine or cosine, I'll just do sine for all of them. Amplitude. Remember the period, that number does not go in the equation. We need the b value, which is 2 pi over the period, which in this case is 1 over 4. Then it's going to be x, the opposite sign, 2 pi over 3, and then a vertical shift at the very end. All right, next one, amplitude is 1, so I don't need to write that. Okay, it's just out in front. Let's find our b value. So it's 2 pi divided by 3 pi over 4. So 2 pi over 1 times 4 over 3 pi. So that's going to give you 8 over 3. Phase shift of pi over 6. And then no vertical shift. All right, last one, reflection over the x-axis. The b value is 2 pi divided by pi over 6. So 2 pi over 1 times 6 over pi, which is 12. There's no phase shift, so I'm just going to go ahead and put x, and then minus 15 at the very end for the vertical shift. All right, so now we're going to find these things from a graph. Again, there's more than one way to write these equations, but remember, what's the only thing that's going to change between your equations and change between sine and cosine is the phase shift. The other things do not change. All right, so let's find those other things first. Let's start with the vertical shift. That's going to be our middle y value, which is at 0. All right, let's find our amplitude. So the height from the middle to the top, that height, that's my amplitude, that's 5. All right, let's find our period and our b value. So find a point in this graph, see how long it takes to repeat. That distance is 2 pi, so your b value is 2 pi divided by 2 pi, which is 1. And then the last thing, again, is the phase shift. Now remember, the phase shift will be different depending on if it's a sine or a cosine graph. So let's start with sine. Let's fill in what we know, okay? 5 sine. Since b is 1, I don't need to write it. And then I don't need any plus or minus at the end because the vertical shift is 0. So if I want to write this as a sine graph, sine starts in the middle before it goes up. So I need to find a middle point in this graph before it moves up. Now there's more than one. I could use this point right here. The x-coordinate of that point is 3 pi over 2. So I could use 3 pi over 2 as my phase shift. But again, that's not the only correct answer. I also could do negative pi over 2. That's also a possible answer. And if you really wanted to, you actually could write this as a negative sine graph and do x minus pi over 2, but we don't need to do that. That's a little bit too much. All right, now let's try cosine. So remember, for cosine, everything is going to be the same except for the phase shift. So for cosine, that phase shift, we're looking for the high point on this graph. So one of them I could use is this point right here. Find the x-coordinate of that point, which is 0. Or I could use this point over here, 2 pi. And I could write this as x minus 2 pi. Domain is easy. Every one of these graphs has a domain of negative infinity to infinity. And our range, bottom to top, is negative 5 to 5 in brackets. We'll always use brackets on the range for sine and cosine. All right, let's do another one of these. So again, let's start with the vertical shift. That's kind of the easier point to find. We're looking for the middle of this graph. Well, here's the lowest, here's the highest. So the middle would be right there at 2. Once we know the middle, we can find the amplitude. So the distance from the middle to the highest point, that distance is 3. All right, so now we know our vertical shift and our amplitude. Now let's find the period. So find a point in this graph and see how long it takes to repeat itself. So I'm going to start from the 0 point. I just think that's a little bit easier. And then this graph will fully repeat itself here. So that point is, distance is 8 pi. So the period is 8 pi. So the b value is 2 pi divided by 8 pi, which is 1 over 4. Then the last thing we'll write is the phase shift, but again, that's going to be different for sine and cosine. So let's go ahead and fill in what we know. 3 sine 1 over 4. So if we're going to write this as a sine graph, okay, if we're going to write this as a sine graph, we are looking for a middle point before my graph moves up. So that point right there is an example of a point we could use. We want the x-coordinate of that point. So I could do x minus 4 pi. Again, that's not the only correct answer, but that's really the only one we can see on this section of the graph. That's probably the best one to use here. If you want to write it as a negative sine graph, that's also possible. All right, cosine. So for a cosine graph, everything is the same except for the phase shift and the word sine. I should change that as well. All right, so again, we're looking for cosine. Our answer is going to be, our phase shift is the x-coordinate of a high point. So there's one possible answer. I could do x plus 2 pi. The other possibility, I could use this point over here, which is at 6 pi, and do x minus 6 pi. So those are all possible equations for this graph. All right, domain is negative infinity to infinity, and range from bottom to top, in brackets, negative 1 up to 5. All right, now we go another way, actually drawing the graph. So hopefully at this point, identifying these features is not difficult. All right, amplitude is 10. Period is 2 pi divided by pi over 24. So I'm going to flip it and multiply. So the period is 48. Phase shift is negative 3. Vertical shift is negative 6. Domain is negative infinity to infinity. All right, so when we graph, we're going to mark the x-axis and the y-axis. I'm going to start with the y. The middle value is the vertical shift. Then I'm going to move up and down by the amplitude. So from negative 6, I'm going to go up 10 and down 10. So that's my highest and lowest point on my graph. Well, now, without even drawing the graph, I can tell the range. The lowest point is negative 16, and the highest point is 4. Now we mark the x-axis. Okay, so negative 3 is negative 3 is the phase shift. Now, since this is a sine graph, I'll go ahead and put a middle point at that x value. Now, the other thing we need that's not listed is our spacing. Okay, so our spacing, we take the period and divide it by 4. So my spacing here is 12. So negative 3 plus 12 is 9, plus another 12, plus another 12, plus another 12, and that'll be enough points at this point to see one full cycle. If you have more points than that, great. The only difference on this one now, it is sine, so we did start in the middle, but notice it was reflected. Normally we go up, so this one instead is going to move down. And there is one full cycle of this graph. All right, let's try a cosine graph. So again, filling out these features, hopefully those are pretty similar. Amplitude, 1, period, 2 pi, divided by 1, which is just 2 pi. Phase shift, pi over 2. Vertical shift, 5. Domain, negative infinity to infinity. Now let's mark our graph. Vertical shift is the middle y value. Amplitude is 1, so up 1, down 1. We have our y-axis marked. The lowest point is 4. The highest point is 6. Mark the phase shift, that's pi over 2. Find your spacing. Period divided by 4. So the first point's going to be at pi over 2. This is a cosine graph, so pi over 2 will be a high point. Now we add pi over 2 to get the next one. 2 pi over 2, 3 pi over 2, 4 pi over 2, and 5 pi over 2. If you want to go back and reduce those, that would be great. So this is pi and 2 pi. Then follow your pattern. Middle, low, middle, high. That's enough to see one full cycle. And just remember, don't graph a V if you just plot that one point. It is still part of a wave, even though we can't see the whole thing. And also remember on these graphs, okay, we do need to know the spacing. We don't ask for it in the chart, but it is something we need to know in order to figure out where these points are going to be. The period just tells you the distance from the first point to the last point. All right, so the last thing we're going to look at are the applications. Now, again, this first one's really good practice on writing the equation. So Tarzan is swinging back and forth on his grapevine, and as he swings, his height varies sinusoidally with its time. So your height and time here are going to make a sine or cosine wave. A swing is a really good example of this. Swings, circular motion, those are the most common things we'll see. So, of course, Jane decides that she's going to model that movement mathematically, because why not? We're in the jungle. So now what we're going to do is actually sketch this graph here. So the first thing I'm going to do is just mark my axes, and I'm going to use a pen instead of a highlighter. So I'm going to let the x-axis be time, and the y-axis is height. And then this one's a little bit easier because it tells us the points we need to know. We don't really need to figure them out. It says that Tarzan's height from the ground, when t is 2, so after 2 seconds, it says he's at his lowest point, which is at 3 feet. It tells us when t is 5, he's at the highest point, which is 17. Well, now to figure out a full cycle of this graph, if it takes 3 seconds to go from the middle to the top, it's going to take 3 seconds to go from the middle to the bottom. And at that point, we can see a full cycle. All right, so now let's try and write this equation. So let's start with our vertical shift, our middle y value. It's not listed, so we need to figure it out. Remember, it's kind of like the average. Add them together, divided by 2. So 17 plus 3 is 20, divided by 2 is 10. So that's my vertical shift. Once we know the vertical shift, we can see the amplitude. The height from the middle to the top is 7. Okay, the period is how long it takes to repeat. So the b value is 2 pi divided by the period. This graph repeats itself after 6 seconds. Sorry guys, you know it is with lunchtimes. All the bells ringing. So the p-value that's actually going to go in our equation is pi over 3. The last thing is the phase shift. And again, this depends on which type of graph you want to write. I'm going to do cosine because I can clearly see a high point on this graph. So if I write this as cosine, my phase shift is a high point. The x-coordinate of that high point is 5. So now we just put it all together. And we have the equation that we need to use. So now we're going to use a calculator to answer these questions. So I'll go ahead and show what to write here, or how to find them, and then I'll actually show you the calculator. So what is Tarzan's height after 15 seconds? So that wants to know what is y when x is 15, and then is he moving up or down? The next one's saying, when was Tarzan 12 feet high for the third time? So when y is 12, the third positive time, what is x? So for part C, we're going to use ycal. I don't know why I wrote that. And for part D, we're going to use xcal. All right, so I have my equation typed in, so I'll go ahead and graph it. Now this is your normal standard window, okay? So from this point, we can't really see our graph. So you got a couple options. You can zoom out, you can scroll up, or you can actually just change the window, okay? So I'm actually going to change my window. I'm going to make my x min 0, just because I know that x is time. I don't really care about negative time. And that's going to give me a little bit of a clearer picture. So again, the first one, it wanted to know what was his height after 15 seconds. So we're going to go to G-solve, which is F5. We don't see our options, so we're going to go to F6. And then we want to do ycal when x is 15. Now I'm going to get an error because it's out of the domain. So remember, that means you either need to zoom out some more, or I'm going to just go and change my window and make my x max at least as large as the value I'm typing in. So I'll make that 20. Now I can do G-solve again, and ycal, I want to know when x equals, 15. And that tells me the height is 6.5 feet off the ground. It also, you can see from looking at that point that you are moving up at that time. Then the second question, when was he 12 feet high for the third time? So G-solve, we'll go to ycal. So we want to know, we want to go to xcal. My mistake. G-solve, xcal, there we go. We want to know when y is 12. So there's the first one. So the third time, we're going to scroll to the right. There's 1, 2, 3. So the third time is after 6.2 seconds. Now remember for this, if you are zoomed out, then this may need to go a little bit different. Okay, so let me go ahead and zoom out here. If I do from this window, if I do G-solve and xcal, and let's say I do y equals 12, the first point it's going to give me is negative. That doesn't make sense for my problem, so I'm not going to count that as the first time. This one's also negative. This one's also negative. So I need to wait to count them until I have a positive x value, because those are the only times that actually make sense for my problem. Then I can count 1, 2, 3. All right, so the last one, it actually gives you the equation. It says the hourly temperature in Dallas, Monday through Wednesday, can be modeled by that function. So I'm going to go ahead and type that into my calculator. All right, so I have that typed in, and when I graph it, I'm probably not going to see it. So there's a couple reasons. Again, the big issue here is our window. This one actually is harder to see because of the y values. So some things to think about. If you want, again, you can just zoom out, and there's part of our graph, and then we can kind of scroll to see some more of it. But it kind of makes sense why this graph is located where it is. If you think about it, the vertical shift was 55, and the amplitude was 15. It's also corresponding to temperatures, and in Dallas, the temperature is usually a little bit warmer than 5 degrees. But again, zoom out if you need to kind of scroll to see your graph if you can't find it. All right, so the first question is asking for the maximum temperature over those 3 days. Well, you actually could figure this out without using your calculator. If you graphed this, the vertical shift is 55 and the amplitude is 15. Well, then I'm going up to a total of 70. But let's say I don't know that from looking at the graph. Well, I can do G-solve max and I can find that the maximum temperature is 70. So that's a different option. But again, this is one we can figure out just from looking at our graph and knowing what we know about amplitude and vertical shift. The next one wants to know what the temperature is at 11 a.m. So it says x equals 0 is 12 a.m. So then 1 would be 1 a.m., 2 would be 2 a.m. So 11 a.m. is going to be when x equals 11. So G solve y cal x equals 11. And I get a temperature of 62.5 degrees. Then the last one, when is the temperature 50 degrees for the first time on Tuesday? So we're going to do G solve. 50 is a y value, so we're going to do x cal, y equals 50. Now again, I need to look at positive values first, okay? Negatives don't make sense for my problem. But I actually have to think a little bit more on this one. It said that 12 a.m. is Monday, which means that x equals 12, so x equals 0 is midnight, okay, on Monday. That means that x equals 12 is going to be 12 p.m. on Monday. So x equals 24 is going to be the next day, 24 hours later, on Tuesday. So if I want to know when it's 50 degrees for the first time on Tuesday, x equals 7 doesn't work because that's 7 a.m. on Monday. So let's scroll to the right. The next one is 22. Well, again, that's not past 24. That's still on Monday. We need to get to Tuesday. So then we get to the next one, which is 31. Now also keep in mind 31.7, we don't really say 31.7 o'clock. It's 24 hours past, so we would subtract that 24 hours, and that's going to give us about when it is. So a little bit after 7 o'clock. We don't need to figure it out exactly, but in between 7 and 8 a.m. All right, so there is a lot of stuff I know on this unit, a lot of stuff with the graphs. Hopefully by now that we've done so much of the amplitude and vertical shift and phase shift and period, that stuff's getting a little bit easier for you. Make sure you review your unit circle and know your trig values. Make sure you know how to draw these graphs and find all the features and write the equations.